Hey there, CS210 students. So in this recording, we're going to go through the details for Project 2. And so as you can see, I'm on the Project 2 link here. It does point out that this project needs to be object-oriented. So all the functionality should be contained to a class. And in my template, we're going to create an investment account class. They do have some sense functions down here, but to be honest, I'm not a big fan of the implementation of these. So I'm going to not utilize those. If you want to take a look at these, you can. I don't really think that they give a whole lot of detail that's really usable. Basically, they're just telling you to use the equation that we were given. In the format of this method where we provide it the investment amount, the interest rate, the number of years, really the only variable that should be a parameter is the number of years. Our investment account, when we create it, we know what the initial investment is, we know what the interest rate is, so really those should not be parameters to a method that we're going to create. So again, I'm going to forego the sense functions here. And if you scroll down, here's the requirements and rubric. So I've got that open. So let's kind of scroll down. You do need to submit some pseudocode or a flowchart that outlines your program logic step by step. So a lot of the details for this is already given. This should only take you, a short amount of time because between the template and all of the information that's in the functional requirements, we have all that information. So scrolling down, creating the pseudocode or flowchart, that should not be an issue. You do need to provide input validation, and as I'll point out in the template, the input validation, you only need to check for valid ranges, positive numbers. We're not going to be checking for if non-integer values were entered. So keep that in mind. Input validation only needs to validate for proper ranges, which means things have to be positive numbers. Make sure that the user interface displays all the things, and then you have to calculate the balance at the end of the year as well as the interest earned. So these charts right here, this is the most difficult part of the application. Note that it is worth 25 points. So what I would highly suggest that you do is make sure that the user interface does what it's supposed to do properly. Make sure you validate the input that we solicit, have a good pseudocode flowchart, and make sure that you adhere to the coding guidelines announcement. If you do those things, you're pretty much guaranteed to get 75 out of the 100 points. Then spend the time to calculate the ending balance and the interest earned. Again, I will tell you this, it's a little bit tricky. It's simple math, but putting it together is a little tricky. Okay? All right, so let's go take a look at the functional requirements. So our account is going to have an initial investment amount. It's going to have a monthly deposit, and then it has an annual interest rate that's compounded, and it's compounded monthly. We also then will have a number of years for how long we want the investment to grow. So this is what the data input looks like. We get the initial investment amount, deposit, interest rate, number of years, and then after they enter in the information, so you can see that they put in 1, 50, 5%, and 5. So when the information is entered, what we get is what the ending balance is, as well as the amount of interest that was earned. This is without any additional monthly deposits. This is where we made an additional $50 every month, okay? So let's kind of talk about this one right here. Let's see if the numbers make sense. So we started out with an initial deposit of $1. And for this one, we were not making any additional deposits. So we see that we started with $1. We earned 5 cents of interest, which means our ending balance was $1.05. So that all crunches just fine. The next year, so we started with $1.05. We earned 5%, 5 cents on that. So when you add these two values, you are now at $1.10. Okay, so everything is looking pretty good here. Let's talk about this one right here. So we started with $1 plus we would have made 12 monthly payments of 50 bucks. So we put in $601 of money. The interest calculated was $16.55. So if you look, if I add $16.55 there, oh look, That's what our year-end balance is, okay? So we want to display these values just like you see here. And oh, by the way, in my implementation, and even if you are just using cout statements with the formatting, I'm not going to penalize you if you're a penny off, okay? So if you're a penny off, that's okay. If you're more than a penny off, that means you've got a calculation error. But it is very difficult, since these are doubles, to represent things properly. It doesn't matter if you're using rounding, cout, formatting, it's pretty difficult. But for our purposes, within a penny, that's going to be just fine. Okay, so this is what we want to display. Okay, so this is what we want to display. Let's go take a look at the template, and then we'll come back and kind of talk about how we calculate these year-end balances and interest earned. So here is the header file for the investment account. You have two constructors. Let me even back up further. We have private member variables for the initial amount, monthly deposit, and annual interest rate. So again, the idea here is these three inputs, the initial amount, deposit, annual interest, that is not going to change. Regardless of how many years we're running it, that information doesn't change. So those are going to be the member variables of the class. So a constructor that takes in the initial amount and annual interest rate. Oh, by the way, the monthly deposit here is 0. We're not going to make one. Okay, so that's why it's not included here. Then we're going to have an overloaded constructor where we're going to have initial amount, the annual interest rate, and then a deposit for each month. So we could have left this potentially as a default parameter, but I like to have constructors that are very specific. So we'll have a parameterized constructor with just the initial amount and annual interest rate, where you'll have to set the deposit to be 0, and then this would set all three of those fields. We then have getters for those variables, so very straightforward, shouldn't have any issues with those. And then I have a method called get ending balance, and you can see here where we provide it the number of years. So that makes sense that if I want the ending balance after 5 years, then I call this method providing it 5. Same thing with the interest earned. We provide it how many years we want the interest earned to be calculated for. So again, I deviated slightly from those methods that they had. I think this just makes more sense as far as encapsulating and wrapping up the information. All right, so these methods return a double. So these are going to provide what the full values are going to be. Remember, this is a banking application. As we're calculating things, we would not round anything until the very end. So in the end, that's where we want to round the ending balance, round the interest earned for display purposes. So same thing here. I'm going to provide the number of years parameter here. What these will need to do is they're going to need to use some helper methods that I provided for you. So I've got implementations for a round method and a format method. So if I go look at the investment account class, again, I've given you this code right here. So I've got code here to round a value to a certain number of places. So you would provide it a value, and then we're dealing with money, so this should be a 2. And this code right here, as I point out, it works for most values. It's not guaranteed to work for all values. Again, long story short, ideally what we would really do is we would have a class for the balance, and we would save off the dollars part and the cents part as integers, and then eventually combine those together. But I think it's beyond the scope of our class. Being within a penny is just fine. Again, I've also got a format method here. So this is going to take a double value. And what this does is it's going to make sure that it gets rounded appropriately and then displayed with the formatted value. It does not append with any zeros, so the value should be rounded prior to use. So basically what you're going to do when you call and use the formatted methods, as I point out right here, you're going to use format and then round to return the values to two places, okay? All right, so let's go take a look at how they are calculating the ending balance. So let's go back to right here. So if we scroll down, they give us the formula for calculating compounded interest. So right here is the formula that they're going to give us. And they give us a little spreadsheet showing how these things are going to be calculated. So let me kind of get this so we can see everything at one line. So I think the first one's pretty straightforward. We start out with a dollar. The deposited amount here is always $50 in this case. And so we have a total of $51. So in the formula, you can see that they took the opening amount plus the deposited amount right there. So we have $51. Then we're going to take our interest rate, which is 5. They're going to be typing again as 5. So we have to divide it by 100 to turn it into a decimal, and then divide it by 12 because it's an APR. So the 21 cents comes from the fact that they took 51 times 5 divided by 100 divided by 12. So we get the 21 cents. You can see that they rounded it right there. So closing balance after 1 month is the $51 that we've deposited total plus the 21 cents in interest, okay? Next time through, our opening amount is the same thing as our closing balance. See that? We're going to add $50 to that. So that gives us $101.21. So now they're going to take $101.21 times the interest rate, 5%, divided by 100 to turn it to a decimal, divided by 12 because it's an APR, and now we have 42 cents of interest earned right there. So 101.63 is what you get when you add those two values. So if we continue this chart, so if this chart were to continue down, at the end of 12 months, remember this is a monthly calculation, at the end of 12 months, what we would see is $617.55 with $16.55 of interest, okay? We would see that if we continued this pattern right here, okay? So that's the math that's going on. How do you implement this in code? So let's talk about that. Okay, so what we need to do is we need to loop from 1 month until number of years times 12. So we need to calculate, remember it's a monthly calculation, so if I want 1 year, we have to calculate 12 months of compounded interest. If it's 5 years, it's 60 months of compounded interest, okay? So we're going to loop, and we're going to use the formula. So let me go find our formula. So this right here, this calculates the interest right here. So we have to calculate the interest. So calculate the interest, and then we have to put the pieces together. So eventually what we had to do was we had to take what our opening amount is, and really I'm going to call it closing balance. Okay, so instead of using opening amount here, I'm going to call it closing amount. So prior to this, we have a closing balance variable. So closing balance, what does it need to start out as? So let's think about that. If I replace this and call it closing balance, what does it need to start out as? This $1. That's our initial deposit. Okay, that is the initial deposit that we have. Then we're going to loop, we're going to calculate the interest for the month, and then again, we had to put some things together, so let me get that spreadsheet. Here it is. So what did we put together? So our closing balance, this is accumulating, so we have to take what it was before plus the monthly deposit plus our interest earned. I got the wrong one. Let me do this line right here. Let me see if I can get this right. So we had 51.21 plus 50 plus 42 cents. There we go. So there's that 101.63. So we have to add together the previous closing balance, the deposited amount, and the interest that was calculated. So closing balance, the monthly deposit, and the interest earned. And again, this is a sum that's getting accumulated to, and then all we have to do is return that after the loop, and that's it, okay? So that is how we calculate this ending balance right there. Let's talk about getting the interest earned. And I've got those in the wrong spot. That really shouldn't be for the balance formatted. This is going to be going for the ending balance right here. Okay, so now let's talk about how do we get the interest earned. So let's look at the little spreadsheet that they have here. And we can do the interest earned, taking a look at an example here. So if we have year 2, 3, 4, 5, any year after year 1, okay, so we have to have a decision structure here. So if year is not year 1, okay, so if the year is not year 1, here's what we can do. We can take any 2 years and calculate their difference. So I can call my get ending balance method for the year and then the year minus 1. So let's see here, 1946.9 minus 1265.65. So the difference between these two is $681.25, okay? So we're going to get the difference between any 2 consecutive years. So we've got, again, $681.25. Keep in mind, a part of this right here, this includes the initial deposit as well as all of the monthly deposits. So in our case, the initial deposit was $1, and we made 12 months of $50 payments. So when I get rid of that, oh look, we have the $80.25 left, and I think I missed something. Where did I miss a calculation of? Hang tight, let me see what I did. Okay, I figured out what my mistake was. So initially I did this. So again, I can pick any 2 ending balances. So I get the year end balance for year 3 minus the year end balance for the year before. And I mistakenly took off the dollar that was the initial deposit. I don't need to worry about that. What I do need to worry about is the fact that between these 2 years right here, so between these 2 years or any of these pairs, we would have made 12 deposits of $50 in this case. That gives us our interest earned for that one particular year of 81.25. And again, just to make sure that we're good with that, 35, 40, 15, 76 there, minus 2663.01, minus, again, $50, 12 months, that's 600 bucks. So we get the $152.75 there. So that is going to be what we do. So the difference between any 2 consecutive years, subtract off the monthly deposit for 12 months. Now, you may be thinking to yourself, well, what about if I don't make any monthly deposits? Okay, so let's talk about that. So what if I was making no monthly deposits? Well, in your code, you will use the monthly deposit, but if it's a 0, when you multiply by 0, right? So if I do 12 times 50, again, we know that's 600. But if I don't have any, 12 times 0 is 0. It's going to work just fine in code, and it'll be a 0. And you don't have to worry about, checking if it's 0 or anything. So have no worries. This will work regardless of if you have a monthly deposit or if you don't. Just to make sure we're good, $1.22 here minus the $1.16. And again, in my code, I would have minus 12 times a monthly deposit of 0, and I still get my 6 cents that I earned that year, okay? All right, so that's if the year is not 1. Otherwise, if the year is 1, let's talk about what we do there. So let's get our spreadsheet here. So $617.55. So I get the ending balance after 1 year. Minus, again, we know we're going to make 12 monthly payments of $50. That leaves us at $1,755. How do they have $1,655 here? Well, that's easy. In this case, we have to subtract off the initial deposit. So if we have year 1, it's the difference between ending balance at year 1 and the initial deposit. And then again, we do the exact same thing. We subtract off the monthly deposit for 12 months. So not too difficult to calculate that interest earned, okay? Now, again, as I mentioned, doing this work right here, this is the most challenging part of the application. Remember, that's worth 25 points. So what I would recommend that you do is that you get the constructor hooked up, you get the getters hooked up, you get the get interest earned formatted, get ending balance formatted methods hooked up. And then for temporary purposes, you could just return a simple value in these methods. Okay. So just return something, return 10 for all that matters, right? Excuse me, for right now. And then go to the project2.cpp implementation file. And the main method, this is really simple. All you're going to do is get the input, and you have to use loops to validate that the values are non-negative. So simple. Then you're going to create 2 investment account variables, one that has a monthly deposit, so call it monthly deposit account, create it, and then create one called without monthly deposit account. And then display the output. So I've given you a prototype, give it an account, give it a number of years, and we want it to display the output just like we see right here. Make it display this right here. So you'll loop through years 1 until number of years, and you just call the get ending balance methods. Pretty simple. Call the get interest earned methods. Pretty simple. And I'm not going to be picky about the formatting, spacing, equal symbols, stars. None of that is an important detail. What I'm concerned with is you're displaying it properly, and then keep in mind, eventually, to get full points on the chart, you have to have these values calculated properly. So again, I would just recommend start simple, just get them to return something, get all of this hooked up and functional, and then go worry about getting the correct values calculated. All right, one last thing. So just like in Project 1, I do provide a test.cpp file. And for some students were telling me that it was not quite cooperating and working. So if that's the case, make sure that you're running on your local machine. On a Porto, it's probably not going to work. But I do have some test cases here where we are going to create an investment account here. We're going to use the exact same values that were provided in the demo. And so you can see I'm going to create my account. I've got 1, 5, and 50. I'm going to calculate my interest rate. I'm going to calculate making sure that all of my values that I entered in are correct. I do have a tolerance of a penny, so everything gets checked against a tolerance of a penny. So I've got a test that'll run, making sure that we get all the values back correctly. I then create an account without monthly deposit. You can see right here, I just called it account. I could have called this account 1. account to, but make them more meaningful. Account with, account without, something like that. Again, I check that the getters are all good. Coming down here, these are the expected balances for ones with a monthly deposit, just like I copied from the rubric that we have. So I go through and I grab each year and make sure that they are correct. So accounts, coming up here, I'm going to do its get ending balance. There's a similar one for the interest earned. So we're going to call the account get me the interest earned, and making sure that it is again within a tolerance of 1 penny. So again, these are all hooked up in here. I've got a red squiggly in here. What did I do? All right, that should clean that up. That's all good. So if I run this to start with, it should completely crap out. Oops, I gotta set the other, gotta do the set startup project. Hang tight. Let's close that. Right click, set as startup project. So if I run this, this should completely fail because I don't have the CPP file implemented. Yeah, that's not gonna work. I do have an example I'm running on my other box, so keep in mind. So if everything is good to go, then you'll get all greens for these test conditions. If something is not a green, then that means there's an error that you'll have to go back and debug. And again, we go back to the other project, set as startup project, and there it is. Okay, so again, a lot of information here. Start simple, just simply get the investment account hooked up with its fields, eventually hook up the get ending balance formatted, interest earned, and you can temporarily start these out just returning some dummy values until you get the math correct. Okay? All right, I will talk to you next time.